So yeah, welcome everyone. Good morning, good afternoon. I will talk about rethinking comfort within human building resilience, which is based on a chapter which can go into more detail, which was just published in the Handbook of Resilient Thermal Comfort, which I can recommend everyone to buy and read the whole book, actually. Many interesting aspects in this book. But let's go to the topic of my talk, rethinking comfort in human building resilience. Before I go to talk about the comfort, I like to start to rethink what is resilience when we talk about it. And when I do so, I sometimes start searching in Google to see, okay, what do others see? What do they refer to when they talk about resilience? And I started to check what is resilient buildings and what shows up. And I like these images. And interestingly, if you Google resilient buildings, I would be curious to know whether the same happens to you, as we have independent individual algorithms. At least for me, it came up a lot of skyscrapers, high-rise buildings, which I personally think are the least resilient buildings which we have. But I will get back to that later. So from my perspective, resilience, and I will talk about a very tiny part of resilience, as resilience is a very broad concept. I will talk about thermal resilience of buildings. And for me, thermal resilience starts with a load. This is a load which builds up, can stay a while or not, and then disappears, maybe because a user in the building has done something, has left the room, or maybe if we consider the load as a heat wave, the heat wave is over, or the heat of the day is over. When we then talk about the building resilience, we can see that there might be specific aspects of the building characteristics like thermal mass, shading, openings, the HVAC system, the indoor environmental quality controls, which affect how the building reacts to this challenge. And I categorize these first in the first phase in the robustness of the building. To what extent does the building follow the indoor thermal conditions? To what extent do they follow the thermal load which is imposed to the room, either from external or from internal? So how steep is this curve? How fast does the building react to this load? Will there be an equilibrium between gains and losses? At what height was this? And how long will this remain? And then we have the second phase of resilience, the elasticity, which characterizes to what extent, how fast does the building, do the thermal indoor conditions go back to the original status from before, or maybe to another status. So we have different aspects here of the building. And when we take the case, for example, of active cooling systems, we could say, okay, with an active cooling system, no matter how the building is designed, we just need to properly size the system. We can completely reduce this effect indoors, no matter what thermal load we have, and we can lead to a maximum relief in terms of thermal indoor conditions. So just enough power, we have the indoor conditions controlled and a maximum relief from the thermal conditions for our occupants in the buildings. But the question is this related also to a maximum of resilience? And is this also related to a maximum of well-being and health? I have my doubts, and I will say so why in the next minutes. First of all, if we stick to the building resilience, there are sort of misunderstandings and problems if we talk this sort of high resilience of a building provided by an active system. First of all, I think most of you will know, the tighter we make the temperature bands within the temperature range within the building, the more energy we use. This is a study from the US, from Hoyt and colleagues from 2014, who are showing that by each degree C, we can extend this range. We can have a decent amount and sometimes even very large amount of savings. Another aspect, if we do it wrong, one man's joy of a cool room could be another person's heat or noise. Just imagine a person in this room here behind this window. I hope you can see my mouse behind this window, trying to sleep in this room naturally ventilated. I doubt this person will have a really pleasant sleep due to the heat and also the noise dissipated from all these active air conditioning systems. And we also may see that the building is rather resilient and we have hardly any changes in the inner conditions under normal conditions. What happens in the extremes? And New York Times cited a study last summer where the authors did some analysis, and they said that the combination of blackouts and extreme heat may be the deadliest climate-related event we can imagine. I think this is easy to understand if we have buildings which are solely designed for active conditioning, which rely on active cooling, likely rely on electricity, depending on your system. And if this leads to a blackout or for other reasons you have a blackout, then these buildings are horrible to live in. But when we get to the users, and Eve said active house is promoting the view on the users and away from energy. I think relief is nice. I would say most of you would agree with me, probably that sitting on a sofa for some while, having some relief, having no stress is very nice. And you may wonder now why I have this fruit salad here. If we would see each other, I would ask you who of you would like fruit salad, who loves fruit salad. And usually, I would say 95, 96% say yes, they like it. A few don't like it, but it doesn't really matter if you like it or not. The question is also here, do you think it's healthy or is it not healthy? And most of us, I think, would agree it's not healthy. And if you, it is healthy, sorry. And for those of you who would say it's not healthy, just imagine another food you think is healthy. When we agree that we may like it and that we feel it's healthy, I would like to know what is if you will have fruit salad the whole week or the whole month or your entire life. Would you still like fruit salad and would you still believe it's healthy? I hope you get the point that when we have always the same conditions, things that we initially believe they might be healthy or supporting our well-being might be changing. And therefore, I started to add the human dimension to this sort of building human resilience framework. And you can see here now the green line in the bottom is the thermal strain for the occupant due to the thermal stressor in the building. So if we have a building which is not completely cutting off all the thermal exposure due to the heat wave, there will be some thermal strain for the occupants. And again, here we have many personal characteristics of the occupants who decide whether the thermal strain is quite high or whether the person is reacting quite fast to this evolving stressor, and to what extent how fast the person can recover after the heat stressor disappeared. And in all of these terms, we see that besides physiology, behavior, perceived control, and personality, we also have the adaptation level, which decides to what extent the person will react to the conditions. And therefore, it's time to rethink the comfort, to rethink that it's not only the relief we need to provide, but something more. And when we talk about thermal comfort, usually most people, they are familiar with the predicted mean vote concept by Fanga, which predicts the mean vote between hot and cold of a large group of persons, depending on the 6 factors. I think there's nothing wrong about that. The problems start maybe when the decision was made to say, okay, the 3 middle votes, they are related to something which we call comfort or neutrality. And in recent times, I have seen also many who relate again these 3 middle votes, the neutrality, to well-being, health, and also to resilience. I have my questions. So for the first relationship between these two, I think we also need to know whether relief is everything. And I believe it's not only the relief, because in order to reach some well-being and comfort, we also need to provide people with opportunities for adaptation, which we could call encouragement. And also, it would be nice, I think, if we can design buildings which will enable us to perceive some enjoyment. The concept of alesthesia, which was coined also in the 70s by Kavanagh, brought up again by Richard Didier in 2011, 2012, and is appearing in more studies these days. So there are 3 levels of comfort. And getting back to the basic level, what do people really feel comfortable when we talk about conditions? I would like to show you one small example of a study we did in 2019. We called the study the scale study because we wanted to know whether this first relationship, which I showed you between the thermal sensation, which we could call you the perception of the people between cold and hot, is actually really related to the comfort people perceive. And here we asked, provided more than 8,000 students with a questionnaire. We prepared for that. These students were distributed in 59 cities. That's the red spots you see here all over the slides, distributed in 32 countries. And what we saw that we have several subgroups here regarding the relationship between the perception of the intensity between cold and hot and the perception, the evaluation of the comfortable conditions. If you bear with me here in the upper right one in subgroup 2, you can see, okay, this group is right in line with the assumptions which are often usually made that something between slightly cool and slightly warm is perceived as comfortable. I plotted here the number 1,900 roughly, so this is only 1/4 of the participants in our study. We found another group which is inclined to say that rather the warm conditions are more comfortable. Group 3 here, which is having a very wide range of comfort, so even from cool to slightly warm is comfortable. And these groups 4 and 6, they say more towards the cool or even the cold conditions, they are comfortable for us. And we could see that the membership in a group depends on the season, whether people are in winter or in summer, and also on the climatic conditions they appear. So the conclusion here is that we need to be very careful what we talk about when we talk about thermal comfort and how we assess this. Current standards are all based on these 7 roads, but the relationship to comfort, to neutrality, is not very clear. I would say there's not a direct relationship. And I also doubt the relationship to well-being, health, and resilience. There's less research on the second part, but an example is, for example, presented by work done in the Netherlands. There's one study, for example, by Hansen and colleague, which showed that cold exposure increases insulin sensitivity in patients with type 2 diabetes, which is a good sign. So so-called discomfortable conditions lead to a higher health state. And the same was seen also for the warm side, so passive mild heat exposure lowers fasting glucose, insulin, mean arterial blood pressure in a study by Hanna Polowinski and her colleagues. So there are signs that some discomfort, some encouragement for people is relevant. So if we put this together, coming to the end of my 50 minutes I have, this is showing the whole human building resilience framework, where I think it's very important that we consider both the building resilience and the human resilience together, and do not start to focus only on the building resilience to remove every exposure the human being might have, because I'm right now, based on the studies we have, it seems to be important that we have some discomfort at some time. And this allows also several aspects related to more passive systems without having to reduce all the exposure by maximum relief. And related to the also this webinar title, Dump Buildings and Smart Users, the studies we do in this line, they show that users are quite smart. A study here where we just wanted to see how people react to different effectiveness of controls. We saw that in what's here the I+ condition, the condition where the ceiling fan people had was normally working, operating. people used it with a lower speed compared to the condition IP here, where the ceiling fan, we put a button, switched it, so it returned the other way around, and it was less effective. And people didn't know that, but still they used it on a higher stage. So unconsciously, subconsciously, they increased the speed. And sometimes they also react quite surprisingly. People putting a drinking bird, which is constantly moving in front of a motion sensor, was at worst because they were not agreeing with the algorithm. And these occupants here in the bottom, they put a rope on an automated blinds because they had no other control. So besides knowing that we encourage people, we also need to give them the chance to interact with the building and to achieve the conditions they want and they need. And with this, I'd like to thank you for your attention, and I pass the floor to Marco Imperadori.